Welcome to the Open Mainframe project stream in Virtual Room 4. My name is Maymolyn Meener, and I'm the Director of PR and Communications at the Linux Foundation and the chair of this session. This session code is 4D, D as in dog, and it's titled The Basics on Using Python with zOS, presented by Stephen Pittman, compiler developer at IBM. A few housekeeping notes. This session is being recorded and will be available after the conference. If you have questions, please submit them in the chat window. And then after the presentation, we ask that you please provide session feedback online from the links on the agenda or by scanning the QR code that Stephen will have on the last page of the presentation. With that, Stephen, I will hand it over to you.
Yeah, so I don't know if they can actually unmute, but if you guys got questions like during the presentation, I'm fine to take them, but otherwise we can just have them at the end. Either way is fine for me. But so hello everyone. So I'm Stephen Pittman, the technical lead for the IBM Open Enterprise SDK for Python. So that's just Python running on zOS. So today we're going to be doing the basics of my slides are not swapping. There we go. Okay, and I'm going to be doing the basics of Python on zOS. So I actually gave this presentation in person in the last GSE UK, so back in like October or November. But things have kind of changed for Python. So even if you were there at the time, I'm just going to be showing you a bunch of new stuff as well. Um, so let's take a look at our agenda and then we can get started. So first up, we're just going to be going over like what is the motivation for me doing this presentation. Then we're going to take a look at Python itself, what's in the offering. Then we're going to kind of dig into the actual meat of the presentation. So like, how do we run Python? And how do we integrate Python with already existing workloads? Then finally, we're also just going to cover some machine learning for IBM zOS. And that's just how you run your AI workloads on zOS, but it's powered by Python. So first up, kind of why am I giving this talk today? So we're lucky to have lots of contacts with various clients, and they tell us that they want to be running Python for various reasons. It could be like to automate some given task or run some AI workload on zOS. But they tend to have a lot of the same questions. And one of the more common questions they have is how do they actually integrate Python into their existing workloads? So for example, like lots of these clients are running their workloads in batch. And so running Unix tasks is kind of a mystery to them, and it's not something that they're super familiar with. So we're just going to be going over how do you actually do this? So first up, the Python interpreter itself is running under Unix system services. So it's a Unix application. It contains everything that you need to get started with Python. So it's the standard library, it's a few extra tools and packages, and I've listed a few of them here. Pip and VM, I'm going to be explaining those in the next couple slides. So I'm going to skip them for now. But cryptography here is so that you can do cryptographic tasks. CFFI is for calling shared libraries on your system. We did add a few additional features for zOS though. But if you've ever worked on zOS, you know there's various encodings that are used. So you might have a file encoded in EBCDIC, it might be in ASCII. We added auto conversion for Python, so that if you write your scripts either in EBCDIC or ASCII, it's just kind of work. And this is also takes effect for if you're trying to read or write files. If you just like read something in EBCDIC, if you read something in ASCII, it's just going to work. We've also added a few additional encodings. So most of these are just EBCDIC related encodings. And then finally, we've also added ZEDC support. So ZEDC is hardware for doing compression and decompression of your archive files. So like a tar file, for example. So instead of doing this compression within software, it's going to be doing it in the hardware. So nice performance increase. Now, there's two currently supported releases, which is Python 3.12 and 3.13. They support all of the Z CPU generations and all zOS versions. So if if what you're running is supported, you know, Python's going to be able to run there. There actually is Python 3.11, but it's out of support tomorrow. So we can kind of ignore it. But if your Z system has a zip processor and it has the latest PTFs installed, Python is eligible to be offloaded to your zip processor for up to 70% of its runtime. But not everything is actually offloadable. So you can kind of just head to our docs to find out what is eligible. But if you're wondering what is a zip processor, within a Z system, when you actually order your box, um, you can have a whole bunch of different CPU classifications. So they can run kind of different workloads. So you have your GP, which is your normal one, which runs basically anything. But then you can have the zip processor, and it runs just specialty workloads, and Python's among one of those. Now, finally, Python's easy to obtain for your systems. So you can just grab it off Shopsy using SMP, or you can download the PAX archive and just transfer it to your machine. We do have a new way of obtaining it though, which is the zOS container platform image. The zOS container platform, it's a way of running native zOS Unix containers. So if you want to containerize your Python workload, there's a pre-made container just for doing this to get you started, and it contains everything that you need. One note though is if you're familiar with something like Docker, within zOS, we're actually going to be using Podman. So it is slightly different, but mostly it's all the same. And I'll be showing you a demo of that later, so you can actually see what it looks like. Now, one thing to note though is Python is a bypassable requisite for zOS as well. So when you're ordering zOS, you can just have Python included in that order. So it's kind of made really easy to get access to. Now, finally, all this is available for no charge license, no charge subscription and support. So all you got to do is just obtain Python and you can just start using it. You're good to go. So let's take a look at two packages that I mentioned earlier. So the ones that we had skipped. So pip is the package manager that comes with Python. So you can do things like building packages or installing them, uninstalling them. But note that a Python package doesn't actually necessarily have to be written within Python. So it can be written in like C as well, or something like Fortran. So if you have some low-level task that needs to be done in like C or assembler, this is kind of one way that you can do it. And we're going to be doing a demo of exactly that later on in this presentation. But you can install packages from multiple locations. So pypy is .org is the default, which is the Python community's package repository. But if you don't want to install it from there, you can kind of install it from a multitude of other locations. So like IBM offers the Python AI toolkit, so it's just another package repository. But you can also install your packages from like a local file, or you can install it from your SCM like Git or GitHub. But to install a package, if you look at the bottom of the slides here, you can just write this command, and it's just pip3 install, and you put in whatever your package name is or wherever it's located, and pip's just going to try to install it from there. Now, virtual environments. So this is the last package before we actually get started on a couple demos. So VMV is virtual environments, and a virtual environment is made so that you can isolate your dependencies for a given project. So the reason that you actually want to do this is that when you're working on various Python projects, these projects can have like the same dependencies, and those dependencies, like they could be at different versions. So package your like project one could have some version, your second project can have another version, and you need to be able to separate these in some way. So the idea is that you create an virtual environment, and then or a virtual environment for each project. You install whatever packages that are required for that project, and then that one's completely separate. Then when you have your second project that has whatever it needs, you do the exact same. And since they're separate, you don't get any package conflicts, and things just kind of work. Okay, so let's kind of shift gears now and talk about what the actual issues are. So Python, um, people want to be able to run Python in a whole bunch of different environments, but they also want to be able to interact with those different environments. So we're just going to kind of go over both. I had mentioned some of the different environments earlier, but specifically, we're going to be talking about Unix system services. We're going to be going over batch, so like using JCL. We're going to use Rex, which actually you can run on a whole bunch of different environments. And then we're going to be looking at the zOS container platform. We'll also be writing a package, a Python package that uses high-level assembler, so you can see what does this actually look like. So our very first demo, it's just going to be running Python in its native environment. So that's Unix system services. So if people are familiar with like Linux or any of the other Unixes, this is just going to feel like home. It's going to be very, very basic, and it's going to be very familiar. However, not everyone working on zOS actually uses Unix system services. So that's why we're going to just start at right at this point. All right, so let me minimize. So the way I've got this structured for this demo is that we've got a shell script which executes our program. So it sets some environments and variables, and then it runs Python. And then we got a Python script. So I'm just going to go line by line. We're going to actually take a look and see, and I'll kind of explain what does each line do. So if we take a look at these first two lines, we got path and libpath. And so when we export path, it's going to look for the binaries at those given locations. So we're telling it, where do I find the Python 3 binary? For libpath, it's kind of this very, very similar, but it's going to be looking for shared libraries at those given paths. Now, the next up is this BPXK auto conversion. So this is just so that Python can actually do the auto conversion of files. So if you have a file that's written in EBCDIC, or if you have it written in ASCII, it's just going to work with Python. Then finally, Python's a POSIX application. So we need to set POSIX mode on. And so we also want auto tagging of our files. So when we create a new file, the file gets tagged with the correct encoding. And so that's what this line does. Then finally, we're just going to run our quick Python script. So if we take a look at that Python script, it's the absolute most basic. It's just saying it's going to print us a little message, hello GSUK. So let's actually do that, show you. So if you look on the bottom of the screen, I've got I SSH'd into our zOS machine. And so we're just going to run these scripts. And you should see just hello GSUK, which you do. So that's really all there is to actually running Python. As long as you set up your environment variables correctly, you're pretty much good to go at that point. So let's go back to the slides. Okay. So the zOS container platform, it's being able to containerize your Unix workloads. So in this case, we provide an image that contains both Python and a C and C++ compiler. So if you want to build and install any of your packages, it comes exactly with what you need. And I'm not going to be giving you a full demo on what this is because it's kind of the same as the previous demo. But I am going to show you exactly what it looks like. So we're going to take a look at what the container file looks like. We're going to look at what the commands to actually run it or build and run it. And yeah, so let's minimize again. So again, let's start with the shell script. So I had mentioned earlier in the slides that we're going to be using Podman instead of Docker. So that's what zOS uses. But the syntax is extremely similar. So if you see at this first line, we're going to say Podman build. So that's going to look at the container file and build whatever's in there. And we're going to tag it with this tag, so Python image. Once that's actually built, then you can say podman run. So this RM just means once the container finishes executing, it's just going to delete that container. So that's not actually required, but it's a nice thing, and it's a nice thing to actually get in the habit of using. But that's all it is. You tag an image, or you build your image, you tag it, and then you can start running it. So if we take a look at this, this is the container file. So you can see at the very top, this is how you actually reference our file. So when you say from Python, then 313, that's going to pull down the IBM image, so the one that we provide. And then this contains the Python, it contains your C and C++ compilers. So at this point, you've got a Unix environment that's ready to go. So we're just going to, next, we're going to create a location to store the Python scripts. We'd copy in some script. So if you have like some packages you need to install, you do all of that here. If you need to build your packages, you do that kind of stuff here. But then all we do is say we're going to set our default directory to that new one that we had just created. And then we're just going to run some script. And that's really all there is to actually running Python within the zOS container platform. At this point, it's going to be treated like any other container. So if you wanted to use Kubernetes or something, you can just start using that now. So let's go back to the slides. Nope. All right. So batch is kind of the traditional way of running your workloads on zOS. It's an asynchronous job though, and you just specify what programs that you want to run. You specify any of the inputs, you specify any of the outputs, and then you also specify what to do when the job is actually complete. So for example, if it fails, maybe you want to do some cleanup. But if it's successful, maybe you just want to run another job. And JCL kind of lets you do this. So like if you're familiar with like Bash or your shell scripting, it's basically zOS's version of this. But since it's a very common way of running your workloads on zOS, we want to go over like how do we actually run Python with JCL? And additionally, how do we run JCL jobs with Python? So the first solution, so if we want to run Python from JCL, there's a command called bpx batch or bpx bat sl. It allows you to run any Unix system services program. And since that's what Python is, we can just use that here. You specify your inputs and outputs, you specify your environment variables so that Python requires, and then it's pretty much just ready to use. One note though is that bpx batch by default it doesn't have access to your DD statements. So if you're familiar with JCL, but if you want to use those, there's the bpx bat sl command. This runs it in the same address space, and that gives Python access to those DD statements. Now, to run JCL jobs from Python, there's a product called the IBM Z Open Automation Utilities, or zOAU for short. So it allows you to do a whole bunch of different tasks from Python. So you can manipulate data sets, you can submit your JCL jobs, or you can run like MVS commands. In particular, though, the one that we're interested in is being able to submit the JCL jobs, at least for this demo. One benefit, though, of zOAU, though, is if you remember, I had said that JCL is asynchronous, a couple slides ago. With zOAU, you can submit your jobs and then have it either wait for that to finish, or if you just want to like pull it periodically and wait for that to finish manually. It really makes JCL, like running JCL from Unix system services, kind of much nicer to use. It's much, much more familiar. So let me do a quick demo for you guys running Python from JCL and kind of the inverse as well. So running JCL from Python. So I put a data set of fake financial data, and we're just going to be doing some absolutely basic analytics on it. And all it is, it's just finance. So let's take a look. So we'll start with doing it from JCL. So we have this execute script. It's the same as the others. So all we're going to do is we're going to delete an output file. We're going to touch an output file. So in this case, since JCL is asynchronous, I'm going to be redirecting my output to a file. And so that's why we're going to delete it, just so it's a fresh start. Now, this submit command, this is actually how you run JCL. So it's a zOS specific command, but you just give it some JCL and it's going to run it. So let's take a look at what that actually looks like. So it is a little bit convoluted, but I'm just going to walk through this step by step and we're going to take a look. So if we take a look at the very first one, so it has the / JCL job. So that's just specifying what is the name of the job. So in this case, it's just called JCL job. Then it's going to say step 1. So this is going to be our first command that we're going to be able to run. And so we're going to say we're going to execute bpx bat sl. So that's execute a Unix program. Then we're just going to specify the path to our program. In this case, just Python 3. And then next up, we're going to specify the path to our Python script. So just run.py. Then I had mentioned we're going to redirect our outputs. So we're going to do exactly that here. So with this DD statement, you can just say path equals whatever. And so we're going to pass in that given path. In this case, though, we're going to pass in a custom DD statement, and that's called DD name here. And so that's going to refer to one of our zOS datasets, and it's just going to be input into that file or input into that script. And then finally, you've seen all of these, the environment variables before. They're the exact same as before. So it's just where do you find Python binaries, where do you find the shared libraries, doing auto conversion, and setting your POSIX mode. So since we're running a Python script, let's also take a look at that Python script now. So I had mentioned that we're going to be using zOU, but in this first demo, we're actually going to be using a package called PySFile. And so that's a package from the community. But one of the things that it gets you access to is DD statements directly. And so that's kind of why I wanted to show this first. So all we got to do is say we import a file, and then we're going to specify, we're going to read our data set. So remember within the JCL file, we specified our input, or we specified that custom DD statement called DD name. And that DD name refers to a data set, a zOS data set. So we're just going to say, let's open up that data set and read whatever's the contents within there. So we do exactly that. And if you recall, it's just going to be some financial data. So we're just going to parse it. We're going to calculate what is the total balance of within this given data set, and we're going to print it out. So very, very basic stuff. Now, the last part is, if you recall, we are redirecting it to the file. So I'm going to run this script, and it's going to have no output. But then in a moment, that output will appear in the file. So we'll just take a look at that file. So if we look at the bottom, we can just run the execute. So when you actually execute a JCL job, it'll just give you what the job number is. And so there's a program called SDSF. And if you wanted to actually look up what happened with your job, this is how you do that. But since we're working strictly within Unix, we're not going to be looking at that, at least right now. But you can see, okay, within our given data set, they're holding $80,000 of money. So very basic stuff. Next up, we're going to try running, we're going to run JCL from Python. So because we have to use this zOU package that I had mentioned earlier, we actually have to install it. And so let's walk through our execute script, and I'll explain everything line by line once again. So this first part, this is all the same that I've explained previously. We don't need to go over it again. zOU has a few environment variables of its own, though. So when we actually download and install zOU, it's got a bunch of binaries, it's got a bunch of shared libraries. And so we want to just set our path and our lib path so that Python can find those. Next up, we're just going to do a bit of cleanup. So we're going to create a virtual environment. So this is to make it so it's isolated from the rest of our system. Then we're going to create a new one. We're going to use it. So that's what this activate command does. And then we're just going to install zOU. At that point, we're pretty much ready to start running zOU. So let's take a look at our Python job. So we're just going to import a whole bunch of various packages, and then we're going to submit a job. So if we scroll down to here, you can see we're going to submit a job that's located in a zOS dataset. So it's very similar to the previous one that I gave, except it's just going to return us a whole bunch of it's JSON data with our finance data within it. But since, remember, I said JCL is asynchronous, so we're just going to say, let's wait for it to finish. And once it's finished, then we have all of our output. So we're just going to parse our output. We're going to load it up as a JSON object, I guess. And then it's ready to be parsed as normal. So we're just going to go through it, and we're going to say, let's look for who has the lowest amount of money within this data set. So let's run this. So this is actually going to take a few seconds to actually execute, because remember, we're deleting the previous virtual environment. We recreate it, we install it, and then we run. So if we were just going to be running zOU, it would have been faster, but you can see it's now printed it out. And I can't get rid of this. Sorry, one second. There. Okay, and so you can see we got the person with the lowest balance is some ID, and they got, $3,000 in there in this data set. So very simple stuff once again. So let's go back to the slides and take a look at the next part. Okay, so Rex, it's a programming language from IBM, and there's a huge number of existing scripts that are still running today on zOS. So one of the really nice things that Rex does, though, is it can run under multiple subsystems, and it can swap between them at runtime. The default, though, is running under whatever that you're currently running under. So if you were running under like Unix system services to start, then it's just going to run under that. If you're running under batch, so with JCL, it's the exact same. But kind of the interesting thing about Rex is that you can have it running as either interpreted or compiled. So you either interpret it and then or you can compile it and run that compiled module. So if it's kind of performance critical, you can just compile it and run that. But lastly, it's kind of, while the language itself is not similar to JCL at all, it does have a similar function to JCL, which is this bpxw Unix function. So it's kind of the equivalent of the bpx batch function for JCL. But regardless of your environment from Rex, you can just run Python using this function. So for this next Rex demo, I'm going to be showing you how to run Python from Rex. If you want to see how to run Rex from Python, you can just kind of use that exact same JCL one from our previous example. So we don't actually need to go over that. So, so we got our shell script, and all this shell script is going to be doing is it's going to run a Rex script. So quite simple. Within our Rex script, uh, Rex is actually a little bit different than most programming languages, and it has a thing called stems, and it's basically kind of equivalent to an array. But you can say, we're going to say we want a command, and we're going to specify Python for this command, and we're going to pass in a script. Then we're going to say, we're going to pass in all of our environment variables. And then we're also going to say, we don't really, there's no inputs, no outputs. So it's just going to be straight. We're going to run our given script, and then we're going to print out the output, which is done below. So you can see here, we're just going to say, call this bpxw Unix. So call our Unix program. And then you pass in a whole bunch of the things that we had declared above. So what is the command I want to run? What is its environment? That's the main ones that matter here. Then it's going to print out, it's going to print out whatever is in the standard out and whatever is in the standard error. So in this case, we're going to be printing out whatever Python prints out. So we'll take a look at right now. So for the Python program, it's again, we're just going to be using our financial data set. So we're just going to load it up as normal. This time, we're just going to look at whatever the averages are, and we're going to print out what the averages is. So you can see here, it's going to print out the average balance within this data set. So very basic financial data. So when I run this execute script, it's going to run a Rex script, and then that Rex script is going to run Python. So let's do that. And so you can see here, the average account balance is about $3,000. So yeah, that's all there is really to it. So if you have some Rex script, it's very easy to integrate Python into it. Okay, I do have an example of running Rex, but I don't think we need to cover that. Okay, so let's move on to high-level assembler. So this is kind of the last demo, but the problem is that sometimes when you want to run a service on zOS, that service is actually only available within assembly. So it's kind of a requirement to use high-level assembly. Luckily for us, though, you can write a Python package within C, and then you can just call high-level assembly directly from that. So that's kind of what we're going to be doing. So our last demo today, it's going to be using Python to print to the zOS syslog, so the console. We're going to be using a macro that's called WTL, and this stands for write to log. So there's actually a whole bunch of the different log sources, but for syslog, it's just kind of one of them, and that's the one that actually just WTL writes to. So it just kind of makes it nice and easy. So let's take a look at that, and it's actually a whole bunch of parts. So one moment. Okay. So we have our script here. So this is the execute script. This is all the same stuff as before. So it's set up our environment variables that are required for Python. Then this one is we're going to set up a couple of environment variables for our C and C++ compiler. So we just need a couple flags so that it can compile the assembly. And then we're also going to be specifying to use XLC. So that's just the default zOS C and C++ compiler. Then we're going to build our package. So we're just going to run in there, setup.py to build. So that's how you build it. Then we're going to say install our newly built package. And then at that point, we're just ready to run it. And so let's take a look at what that looks like. So we are building a package called zlog. So that's using that WTL macro. So all we're going to do is say we're going to import zlog. We're going to print it out to a console. And then we'll also print it out to the regular standard out, so your Unix standard out. So after we actually run this program, we should see a message on standard out, and then we'll take a look at SDSF and see it exists on the syslog. So I showed you we're going to build that package. Let's actually look at what the package looks like. Like, how do you actually define a package within Python? So we use I guess the Python community uses a standard tool called setup tools. And so all this does is it specifies, what is the name of your package? So you can see here, it's zlog. What is its version? And how do you actually build it? So since we're going to be including C and C, or I just C and assembly, we have to specify these extensions. And so you do that here. So we have two files. One's a C file, one's an assembly file. So we just include those here. And then setup tools, it just knows how to build this. So if we take a look at the C file first. I don't want to actually go into this too in depth, but if I scroll down to the bottom, you can see we're first going to define a module called zlog, and then we're also going to define a function within this called write to log. So that's what we were calling within that Python script. But other than that, all we're going to do is say we have an assembly file that we'll look at shortly. It's going to do a whole bunch of setup for that, and then we're going to call that function. The reason I don't actually want to cover this too much is it's a bit in depth, and I think it's a bit beyond the scope. But I want to show this is how this is how you would actually do it. And you can find this actually example just online. And we have this within our resources pages at the end of the slides. But let's just briefly look at our assembly file. So again, we can kind of ignore most of it because it's a bit complicated, but you can see we have this WTL macro. So that's going to be what's actually going to be calling the console. So we're going to pass in a string. It's going to print out that string to the console. So that's kind of all you need to know about this file. So let's run it. So it'll take just a moment again because it has to build and install it. And then you can see here, we sent a message to the console. So it's at the very bottom. And so that came from the Python script, sent message to the console. So if we take a look at SDSF, so that's here. I actually have this already preloaded, but if you look here near the bottom, it says a message was sent to the zOS console. So we know this actually correctly worked. And so that's all you have to do to actually build a package. So if you wanted to be able to call high-level assembly within Python. So since we kind of went over all of this very quickly, I did want to note you can get all of these samples online. So we have them all, so you can just get access to them. So you don't actually have to memorize it, or if you want to look into it deeper later, you can. But let's go back to the slides. So kind of pivoting directly from using Python, Python's kind of the main way of running ML in your AI workloads. But there is a product called Machine Learning for IBM zOS, which is MLZ for short. So this is kind of an all-in-one solution for our AI capabilities. It gives you a web UI, it gives you API endpoints, and it gives you administration to control usage. And then allows you just to both develop and deploy your AI models. So, okay. The way it works is that every model that you develop has its own endpoint. So you can just pass in your data to this endpoint in a JSON format, and then it'll be able to run that model. It'll be able to score it and then return, excuse me, that result to you. So it's actually quite easy to use at this point. If you wanted to use that within Python, so be able to touch that endpoint, there is a package called like requests, and it's very easy to use, but I don't have an example of it here. But that's all I actually wanted to show you guys today. So we kind of went over Python on zOS. We went over how to use it in the different environments so that you can both run it and be able to integrate it with your workloads. And then we also went over a brief overview of ML and AI, running ML and AI on zOS. So we got a few blogs and useful links for you guys. So I will be uploading these slides to the GSUK site. So you can find similar examples of basically most of what we've shown here today. Now, one thing I did want to note is that we do have a whole bunch of different sessions within the compiler group at IBM. So most of these are happening on May 1st, so I believe Thursday. So if any of these actually interest you, feel free to sign up for them. So the first one's going to be developing Python packages on zOS. The next one's going to be from me. It's going to be mixing Python and COBOL. So if you wanted to be able to do that. The next one's going to be about Go. So why you should be using Go instead. And finally, feedback. So please leave feedback for this presentation. So any feedback's good feedback. But that's actually all I had. And I know since we went over things fairly quickly, if you guys got questions, like feel free to ask them. And then, yeah, I don't know, do they need to unmute or can they unmute?
I don't think they can unmute, but there are a few questions in the chat.
Okay.
The first one is from Wendell.
Yep.
He's asked, what is the source location of the copy command?
Of the copy command. Uh, I'm not sure which demo that was really referencing.
I think it was,
Can you post into the chat? Sorry.
let me see if I can unmute Wendell. Wendell also asked, do you have the URL to download the samples? Is that,
So yeah, you
is
can
that
just download these slides. So I believe you'll be able to find them within my profile or within this session ID. And then it'll be pointing to any of the downloads that you need or the blogs that actually explain.
perfect?
Yeah.
Jelly, can I trigger this using Jenkins?
Everything here can be triggered with Jenkins, yes. So all the
Awesome.
demos that I did.
Oh, and then Wendell did follow up. He said that his earlier question about the copy command was from the Podman demo.
From the Podman demo. Okay, could you repeat what the question was?
Sure. What is the source location of the copy command?
Oh, okay. Okay, I see. So let's go over there. So within the container file, when you're actually building a container file, this is going to be built on the zOS machine. And so when you say copy, that's going to be in your host environment. So it's saying copy whatever your script is into the container. So, or the container image, I guess. So it's your default zOS Unix is what your source location is.
Awesome. Wendell, did that answer your question? His follow-up is, so running container.py is on your laptop.
It would
Or,
be on your zOS machine, but yes. So when you're building the zOS containers, you're going to be doing it within your zOS machine. Um, yeah. So you won't be building it on your laptop.
great. Does anyone else have any other questions? I know we do have a few more minutes.
Yep. I'll bring back feedback.
Oh yeah, the QR code. Um, Jelly asks, how much mainframe workload does this consume when you try to run it as an automation?
It really depends what you're doing. So that's a really tough question to answer. But will note that if you do have a zip processor, it will be offloading to that zip processor, or it'll be potentially as long as you're within the eligible workload types. Um, so really you're gonna have to try whatever your given task is and actually see. It's hard to answer that.
Okay, it seems like that was the answer she was looking for. Jelly always asks the hard questions. And this one is from Bill. What happens when we have mix of zip eligible and not eligible workload in the Python script?
So what's going to happen is that Python's going to be periodically swapping between zip and non-zip. And so if it's just not eligible, it's just going to stop running on your zip. It'll transfer over and it'll just run. And at some point later on, when it's actually eligible, it'll just swap back. So all of this is automatic. You don't do anything. Python will just be swapping between it periodically.
Okay. I think that might be all the questions. Oh, no, Jelly's back. Can you also instrument those Python apps even though they are on USS?
Uh,
Hotel instrumentation.
I don't know about OTel, what that is, but like if you wanted to gather like SMF data for example. All of this is possible within Unix. Um, so I believe the answer would be yes, but it kind of depends what you're looking for. I know as well that LE, so the language environment, also provides environment variables for checking, how much memory usage did it use or how its runtime, stuff like that. So if you search up the various LE environment variables, you can find that.
And then Neil Adamson asked, will we be able to see if it runs on zip and or how much of it?
Yes, so if you run a workload, if you go into SDSF, generally it'll have an exact it'll have the runtime, not the percentage, I believe. It might have the percentage, but you can just check there and you can see how much they run on your zips. You can also just do the data gathering as well if you want to just like run a whole bunch of Python tasks and then just gather it all up at the end and see. So that is possible, yes.
Awesome. Well, we are at time here, so thank you so much, Stephen, for this presentation. And thank you all for attending. We just ask that you please don't forget to complete your feedback. The QR code is there. If you can't get to the QR code, then the link to the feedback form is also in the link on the agenda for his session. Thank you.
All right, thanks for attending, everyone.